All right, Algebra 2. Welcome back, guys. We are starting a fresh chapter today. Chapter 8, you see it right there on the screen. We're going to jump into section 1 today. All right, chapter 8, all about variation functions. Okay, there's a few different equations. As far as notes go, you're looking right at it. I mean, these are all the note parts, and then, of course, below it, we're going to get into the example problems. But everything you see here, especially, of course, the highlighted stuff, which really is the most important, is right there. It's pretty quick. It's pretty simple. But the other side of the coin, if you will, is that most of these problems are like a word problem style. Okay, so you're going to have to be able to extract the proper information and use it in the right equation. Okay, so the equations themselves are not that hard. All right, take a look at, we got direct variation, just real simple, y equals kx. All right, what does k stand for? Right here, k is the constant of variation. K is never allowed to be equal to 0. All right, so k can't be 0. If it's 0, the whole thing is 0, and that's not going to be possible. All right, this is also important right here. This is a manipulation of the direct variation equation, meaning we took this guy, manipulated it, solved it for k. That's what that looks like right there. You're going to have to use both styles. One style usually is that k equals tends to be done first because you want to solve for the constant of variation, then take that value of k and plug it back into the more original style, the y equals kx equation. Then right here, this is probably the most important piece from this note. All right, this piece right here is that there's a proportion method, because there's going to be some word problems where they're taking one piece of information, comparing it to a second piece of information, except that in that second piece, they're leaving something out. And so you have to make a proportion, like you see here, to solve for that unknown one left out piece. All right, and you'll see a problem in the examples where we do one of those. Okay, then the other style, joint variation. Here's the equation here. You'll notice that it's one extra piece. There's that z piece that's brought in. And for the joint variation equation, or the example problem that we use for that, you're going to see that it's similar to direct, but there's just a couple extra steps because we have extra pieces to deal with. Okay, and then last piece here, inverse variation. Here's what you're looking at. And you'll remember from the last chapter when we did a lot of the inverse functions, you just kind of flip something around and all of a sudden, boom, it's an inverse, right? So here you go. You got y equals kx. Well, let's flip it around. Y equals k divided by x. That's the inverse. That's all we're doing there. Okay, so let's jump into the example problems. Let's see what we got. Follow along with me. Make sure, again, copy it all down. Don't leave any blanks. Don't leave any room for, oh, I didn't think I needed to do that. Do it. Fill in everything. Write it all down. Take the time. All right, ask me questions. You guys know the drill. If you want to learn it, you're going to put in the time to learn it. Okay, here we go. So first example problem, y varies directly as x. If that's how the sentence starts, you know that you are using direct variation. And I've given you guys hints and clues throughout most of these example problems written in red, so it gets you started. But on a test and homework, especially a test, they're not going to really say anything more than this piece right here. Y varies directly as x. That's key to let you know, use direct variation. All right, so let's jump into it. Okay, so the first step is we're actually going to solve for k and then plug k back into the original. All right, y varies directly as x. Y is 6.5, x is 13. You're going to use this equation first. All right, so let's set that up. K equals 6.5 over 13. All right, again, that's the equation we're using right there. This is going to equal 0.5. So k is 0.5. Then take the k value, plug it in to the original function equation, and we are simply going to write that y equals 0.5x. That's all we're looking for, because it just says give me the direct variation function. That's what we got here. You can only pose the direct variation function after you have solved for k. All right, let's take a look at the second example problem. All right, the perimeter P of a regular dodecagon. Doesn't matter if you remember any of that part from geometry, because you probably don't. Let's keep moving. All right, a perimeter P of a regular dodecagon, whatever, varies directly as the side length S, and P equals 18, S is 1.5. So you're going to notice they're giving us more information in the second example problem than they did in the first, and this is the proportion method. They do say that it varies directly, so you are thinking direct variation, but there's more numbers here than we have spaces for, so we're going to have to use the proportion method. All right, so let's set this up. We have two shapes being directly compared, and in a proportion, be consistent. You must be consistent. So what I'm going to do is I'm going to say the first P value is going to go over the first S value, equaling second P value over the second S value. So that's a proportion. First shape, second shape, fill in the blanks now. All right, the first P value they give me is 18. The first S value they give me is 1.5. The second P value they give me is 75. But you'll notice they don't give me the second S value. All right, so if you were to rewind the video, go near the beginning, this is when I talked about the proportion. There's 4 parts, but they're lacking in one of the parts. So as long as you set up the proportion properly, everything in the right order, you can solve for that unknown part. And yes, I know my S's look like 5s. Please just remember that this is an S. All right, okay. So how do you solve proportions? Cross multiplication. All right, so we are going to cross multiply, and 75 times 1.5 gives us 112.5. So you're going to have 112.5 equals 18S. And then we need to divide both sides by 18. That will cross out. S will equal 6.25. And that's good, because that's our answer. All right, so we wanted to figure out what was the second side length if our perimeter was 75. All right, let's move on to the third example problem here. And there's a lot of info. They're using pi. I'm going to tell you right now, do not actually solve for pi. Just leave it as pi. All right, thinking of pi as more of a constant than just like the number 3.14 and multiplying and doing all that. Just leave it as pi. And I'm going to walk you through it and show you how it's helpful to just leave it as pi. All right, and I'm giving you another hint. This is a joint variation problem. All right, so joint variation, that's this right here, where we are looking at 3 pieces that we're pulling. Okay, so you have a lateral surface area, capital L. That's the first piece, meaning it's going to be capital L equals, and then everything else. All right, it's going to vary jointly. That tells you it's joint variation. It varies jointly as the base radius r. So just think r. and the slant height L. Now don't forget that there is K. All right, K is a part of this right there. So think of it as we have an L, the K is all there, then we're going to have an R and the slant height lowercase l. All right, so I know, stay with me. We'll write the whole thing out. All right, so first step for joint variation is you have to solve for K. We have to solve for K before we can move in and solve for the other shape. So we have a 63 pi. That came from the first L value equals 3.5 times 18, and then don't forget times K. We have to solve for K. So for the joint variation, there's 3 pieces we have to be using here. All right, 3.5 times 18 works very nicely out to be 63. So here's why you leave pi. All right, so we need to get K by itself. We're going to divide both sides by 63. That will cross out and that will cross out. So what this shows you is that K equals pi. Remember that, because now we need to plug that into the second joint variation equation. That's given to us down here. Here's L. Here's the slant height. We don't know R, but we do know what K is. So let's plug in K, slant height, and solve for R. All right, so we have 8 pi equals 5 times pi times K. Nope, that's not true. Not times K. Times R. That's right. K is pi. All right. Quick solve right there. All right, now how do we get R? Divide both sides by 5 pi because we want to get R completely by itself. Cross that out. Divide, we can zoom in here, by 5 pi. This is why we kept it in terms of pi, because the pi will cross out, leaving you with just 8 over 5. And that is what we're looking at. R equals 8 over 5, which is the same thing as 1.6. That's what they were looking for with all of this work. Okay. All right, zoom out a little bit. Let's do a couple more examples and then we are done here. All right, inverse variation. Again, they're going to say it in the problem. Varies inversely. How do I know which one to use? They will tell you which one to use. All right, so they're giving us varies inversely, meaning we will be using this equation, y equals k over x. All right, given the values, y is 4 equals k over 10. All I did was plug in the values. There's y, plug it in here. There's x, plug it in here. Solve for k. K equals 40. Remember, just cross multiply here. So you would do 4 times 10, giving you 40. K times a 1, sticking with just k. Now, rewrite this as a inverse variation function, and it goes back to now looking like y equals 40 over x. That's it. That was real straightforward here. Last problem, we are going to determine if these charts that are given, these charts are either direct variation, or if these charts are inverse variation, or if these charts are neither. Just use the first two numbers, and that should be more than enough to figure this out. So step one, determine if it's direct variation. If it's not, move on to inverse. If it's not, it's neither. So for direct, we have to do y divided by x. All right, so I'm going to do 12 divided by 3.75. Then I'm going to test 3 divided by 15. Okay, plug that into the calculator. 12 divided by 3.75, 3 divided by 15. They do not equal at all, nearly close, and you should be able to see that right off the bat. So we know that it is clearly not direct. So now we have to check inverse. We're going to do 12 times 3.75, and then 3 times 15. And when you plug those in, work that out on the calculator, that does work. So this one right here is inverse. Okay, now let's test out 6b right here, or actually 5b. I just took it directly from the book. So we're going to check direct variation. Y divided by x, 0.2 over 1. Then do 8 over 40. Remember, it's y over x, and you got to do the first two and check those out. 0.2, 8 over 40. It's also 0.2. There we go. So that was quick. This one is direct variation. All right, that's what I got for you. Section 1, starting chapter 8. All right, take a look. So there's all the example problems on this page and all the example problems on this page. So you can get all the info there for you. All right, ask questions if you got them. We'll see you guys in the next video.